there is some good news actually. It depends on how they want to look at it. The United Nations just announced today that the population globally reached 8 billion. So the number of people and population is growing, 8 billion, congratulations for all of us. Now we need to feed this 8 billion. We need to provide the right education for this 8 billion. And we need to provide the good healthcare and good life for this 8 billion. How do we do that? Is what I will try to answer together to some extent during my presentation today. So when we look at the digital economy, and I claim that this is the solution for our future, when we look at the digital economy is growing at 15.6% average year over year. And most of the companies in the enterprise segment are actually putting the strategy for the digital economy or digital transformation, talking about 42% in the last 2 years, and 16.5% is the average annual transformation investment in the digital transformation. So the fact is, and what I'm trying to say, it is happening. It has been happening now for a number of years. I think it started in 2011 when Germany or the federal German announced or talked about the Industry 4.0, and they wanted to convert their manufacturing industry, which is the biggest source of income in Germany, to be smart. And this was the generation, if you want, of talking about Industry 4.0, and we'll talk about what are the triggers. Why did they start to talk about it in 2011? Okay, so talking about Industry 4 and the digital transformation, and 2011 is a very special year in my opinion in particular, and I said that the federal German said that this is the year to start the Industry 4.0 and transform all the manufacturing in Germany. And that's where the term was generated. Why it was generated or created at then, and they started to look at it? Because of the AI, right? So this was the first pillar, in my opinion, that built the Industry 4.0. And why in 2011 and why AI? So AI actually exists since maybe the 1950s. But the issue was about the computing power the AI requires. So AI requires a lot of computing power, and the technology that was available at the time was not enough and was not commercial viable to use it for the AI applications. So in 2011, actually, before that, we're using the normal regular computing systems. In 2011, the statistical computing was founded, was created, and the world and the technology providers, including Huawei, were able to come up with the first chipset, AI chipset, just for the processing of the AI algorithm. So like we have the CPU, the central processing unit, to do the normal processing of the computing. You have the GPU doing that for the graphics, and that of course was a big transformation, if you remember Silicon Graphics, and moving everything after that to Windows and Apple. The same thing happened with the AI chipset that helped us to do all the processing power of AI on this particular chipset. So that was the creation or generation, if you want, for the real AI where we can implement it in the industry. The second thing is the 5G. So these are two key elements, and I will explain to you again as we go why. When we are talking about IoT, our colleague this morning talked about 36 billion devices being connected globally, and talking about 75 billion devices to be connected in the future. Just to give you a feeling, when we are talking about the 4G, which we are all using in the room today, the 4G can connect up to 120,000 devices in 1 square meter. 5G can connect 1 million devices per square meter. And hence the importance of the 5G when it comes to connectivity as one dimension. The second dimension, of course, is the latency. When we talk about we talked about number of applications this morning, we'll talk about number of applications this afternoon. Latency is a key driving factor if you can implement this or not. When, for example, when you are talking about autonomous cars. Autonomous cars is a car that will take a self-decision to stop or go right or go left or head right or do whatever that they want to do. And for that, you need to have a brain. This brain either to be a very big data center inside the car, which doesn't make any sense, or needs to be on the cloud and maybe some little bit of edge computing, and you need to have the right connectivity, right? And if the car will tell you that I'm hitting an object and you need to tell the car, yes, stop because it's human or you are going to have an accident, then this signal needs to go to the cloud and come back very fast. This is what's called latency. If the latency is high, then you will have an accident, and then practically you cannot apply any autonomous vehicle concept or any autonomous mechanical system concept. And hence the importance of the latency. And the latency, we are talking about 10 times better moving from 4G to 5G. Of course, in addition to the speed and the bandwidth, and again, we'll reflect on the applications, like what we said this morning, you will have real-time data from the digital oil field to the cloud for the decision makers. Again, that's thanks to the speed. If you don't have the speed of 5G, you will not be able to do that. So what I'm trying to get into is, it is two key pillars. It is the connectivity and it is the computing that is generating what we call today Industry 4.0 and what's creating the digital transformation. I want to go more on this and just explain the model, how it works, because I think in the coming slides I will be just talking about examples, but this is the reference. What I'm going to share with you is the reference architecture for any digital transformation of any business. If you're in building management, if you're in oil and gas, if you're in banking, if you're in any industry, and you want to go through the digital transformation, the architecture, the concept for that has four main building blocks. The first one is what all the colleagues talked about this morning. It is the IoT. You have so many devices, billions of devices that you need to connect together, right? So this is the first, and you need to have what's called the intelligent interaction. These devices is not any devices. It has to be an intelligent device that can sense and collect the data you want to collect and send it to you. Then the second is the intelligent connectivity. This is the second building block. Again, Krishna, I think, talked about it. Connectivity will vary from one situation to another. In some solutions, you may need to have only 4G, or maybe 5G, or maybe fiber cables, or maybe fixed 5G. Depending on the situation, you will need to have different connectivity. But the point is, you need to have the right connectivity. You need to have the right speed, you need to have the right bandwidth, you need to have the right latency for your solution. Then the third building block comes the cloud. So you collect the data, you send the data, you need to put the data somewhere to do the processing. So you send the data to the cloud, the data will go there, you store the data, you analyze the data, you process the data using AI and other tools to create the information that and intelligence you need to generate. And then you send this back to the devices to take whatever decision. This could be a panel for a supervisor to take a decision, or it could be a machine that is taking decision to open a gate or close a gate based on the data that's collected. This is the concept from a technology point of view. And as you see, the two main building blocks here are the connectivity and the computing. Now let's talk about some examples. I said at the beginning that we have reached 8 billion people on Earth today, so we are looking, of course, for better education and enough education as well. Same from food, same from health, and so on. So different scenarios of different industries face different challenges. Yeah. So if we are talking about the aviation, for example, if you can imagine, you have a flight from gate number A. And you go there and the flight is delayed for half an hour. While there is another flight that is landing after maybe 15 minutes and is supposed to come into that gate A in particular. Yeah, and the third one and the fourth one, what will happen in the airport? Unless you have an intelligent system to control all of that, then it will be a chaos. Same if we look at the power side, and I think the case here is talking more about the power. You know the power transmission cables, you see it everywhere, and that's very big challenge when you produce the power, transmit the power and send it from one city to another, or maybe from one country to the other. These are like hundreds of kilometers of power cables, and these power cables requires maintenance and inspection. Historically, people used to go carrying bags on their back and climbing the tower to inspect these cables. Right, and of course that the safety factor, the cost factor, and the timing factor is very expensive if you want. Now, what we have generated as a solution, first step was, okay, let's send drones. Instead of sending people, we'll send the drones. So we'll send the drones, and the drones will take videos. We'll take these videos, send it to the control room, and then the people will analyze and say, yes, we see a potential problem here or a problem there. Now what we have done is that we have bought an intelligent computing. We have bought an intelligent camera at the top of the tower, and this camera is trained on what kind of problems could happen to this kind of cables in this environment. And only at the moment this camera will spot a problem in the cable, then on real time we'll be sending all the details to the control room to say, listen, there is a problem happening at this moment in this cable in this location. Of course, then you can imagine the amount of saving from a dollar point of view, from energy, from people effort, and so on. So that here you are talking about 80% efficiency and 90% reduction in the accidents. Again, talking about people climbing towers, that's a very complex job. Here we are talking about another case from a health point of view. Of course, there are many applications using robotics now in the medical surgery, remote surgery, and so on. But again, that depends on the same concept. Always remember the intelligent interaction, intelligent connectivity, and intelligent cloud, right? And again, remember that you need to have a high bandwidth and you need to have a low latency. If a doctor is sitting in the US and using robotics doing an operation in Abu Dhabi and there is a problem in the latency, then he will be moving something, but the robot here will not respond at the same speed that the doctor wanted to do, which is of a very high risk. Another example is if you go and do an X-ray or do whatever, any imaging, health imaging, then you will have it on a film and then the doctor will start to look and see what is the problem and maybe try to explain to you or not, and will take very long time. At best you can see it again black and white on the screen of the computer. But with this technology now you can actually see if it is, for example, on the lungs, then you can see the lung on a 3D and the doctor can just rotate it and move it this side and that side in a color and you can see what's happening in there. When we are doing that, we are talking about 3,000 images just for this one X-ray that we have done, and we are talking about 2.5 gig of data, which is equals like to 2 hours of a movie. So you can imagine the amount of data and the computing power you need to have and the processing power you need to have behind this for you to be able to see the 3D lungs on the screen, which makes it very easy for the doctor to take a decision and also for you to understand what the doctor is trying to explain to you. What we do at Huawei is we actually provide solutions that can build these scenarios along with the ecosystem and system integrators, and we have 26 different products that we are providing for this. Now that's another example of the smart tunnel. So in tunnels, especially when it is a long distance, again it's high risk. And the authorities don't want to have any accidents in the tunnels, because if it happens, then the evacuation is a challenge, and the oxygen and airflow and a lot of problems. And again, when accidents happens, it is very difficult to manage. Of course, all the tunnels today have cameras and have different radars and different systems. What we do, we automate all of that. So we have smart sensors, we have fusion radar cameras that can detect and read the problem, and it has, again, edge computing, including AI, to do the analytics and send the right information immediately to the control room in case of any challenge happening in there. So how do we do that? That, if you can imagine, takes a lot of effort and time, but at Huawei, we believe in the investment in the R&D. This is what makes the future. This is very important. In essence, we're an infrastructure company. We build computing, we build storage, we build networking, we build data centers, but at the same time, we work with our eco-partner systems, and I will talk about that in the coming slides, to build these vertical solutions for us to provide these technologies. But even at the level of the technology, we want to make sure that we are providing the best and latest technology from a performance and cost and power saving point of view. Last year alone, we invested $22 billion in the R&D. In the last 10 years, we invested $132 billion in the R&D. So we continue to invest in the R&D. We see it as a key priority for the company. That's how we are able to come up with new technologies. That's how we're able to come up with the 5G 2 years ahead of everyone else. Now we're talking about 5.5G, hopefully by 2025. We're the first to bring the AI chipset full stack for all scenarios. If we're buying a watch or a computer or a storage or a data center, it has AI integrated into it, and it has the applications in the system, again, thanks to the investment in the R&D. And by the way, we are #1 worldwide in the number of patents today. Here is how do we build it. So first, we work with consultants like the colleagues here in the room to do the design and planning of any engagement. So we try to engage with customers. I gave you an example of what we talked about for the power cable inspection. This actually was a solution that we jointly developed with our customer, Saudi University in Saudi, where they had this problem and said, guys, listen, we have a problem with these cables, that people are cutting the cable at was a certain time of in the past, and we have issues with that, and it's costing us money and power outage, and so we need to have a solution. And hence we work together and with a consultant to develop this solution. And then while developing the solution, we also engage with the different solution providers, because we don't have everything, right? But we have the open lab where we can host the different solution providers and get the system integrator to integrate these solutions together based on our infrastructure, based on our cloud, to come up with a solution that will help the customer and fix the customer challenge. Of course, also we continue to invest with our partners. So in the coming 3 years, we are planning to invest $300 million just to enable this kind of solutions and development. We train almost 70,000 people every year on average. And we have more than 2,000 ICT Academy. This is a partnership we do with the different universities across the globe to train the students. We're talking about the talent and the importance of talent. We understand the importance of that, and hence we make these investments. Okay, so I explained to you how do we make it happen. So of course, as an outcome, we continue to grow our business. Last year, we achieved $100 billion of revenue. Enterprise alone was around 8.17 in H1, growing 23% year over year. We built a number of solutions in the different verticals, but also our products are unique. So for example, talking about our data center switch, it is the only switch in the industry today that has a zero packet loss. Yeah, this is very important when you are talking about, again, any of the healthcare solutions or education solutions and many other solutions that we provide. With that, I thank you very much and I wish you a great day. I hope it was good. Thank you.